This is a follow-up. The last report filed from Kilauea covered the close of episode 47. It covered the pause. It covered the inflation numbers building inside the summit caldera like pressure behind a locked door. And it covered the forecast window for episode 48, which at that time was still a model prediction, a statistical range on a chart, a number accumulating on a tilt meter. That was 12 days ago. Tonight the door is open. At 5:41 inches the evening, Hawaii Standard Time, on the 30th of May, 2026, the south vent inside Halemaʻumaʻu Crater at the summit of Kilauea began producing what the Hawaiian Volcano Observatory describes as precursory eruptions of sluggish lava. That is the clinical language. The operational language is this: the volcano is going. The USGS alert level for Kilauea is watch. The aviation color code is orange. The observatory has stated in its Sunday morning update at 8:06 local time that the forecast window for full episode 48 lava fountaining is today, the 1st of June 2026, and that today is the more likely day within the window. 29 precursory overflows from the south vent have been logged since eruption activity resumed the evening of May 30. Continuous spattering continues at the north vent. Both vents are active simultaneously. The National Weather Service has issued a special weather statement regarding potential ashfall into surrounding communities to the northeast: Mauna Loa Estates, Ohia Estates, Volcano Village, Royal Hawaiian Estates. These are the communities named in the advisory corridor tonight. We are filing this report because what is happening at Kilauea tonight is not simply another episode in an ongoing sequence. Episode 48 is a threshold. It is the number that, once crossed into full fountaining, will set a new record for the most lava fountaining episodes in a single, continuous eruption sequence in the documented history of this volcano. The record was set during this eruption. The current eruption is now attempting to surpass its own precedent. That is the first number you need to hold tonight. We will return to it in the briefing with the full structural context, what it means for the magmatic system beneath the summit, and why geologists are paying attention to it with a different quality of attention than they applied to episodes 30 or 35 or 40. There is a second number alongside the first that most news coverage of tonight's activity has not mentioned. We will reach it before this report closes. Before we enter the briefing, we want to be direct about what this report will not do. It will not repeat what the last Kilauea file covered at its surface level. The traditions covered there, the Hawaiian account of Pele, the Norse Voluspa, the Vedic framework for fire and renewal, the Maori understanding of Rauamoku will not be walked through again at the introductory level. You already have that foundation. What this report will do is go deeper into each of those traditions than the previous filing had space to go. Because every one of them has something specific to say about iteration, about what the tradition understands happens when a fire cycle exceeds its prior count, when the number of eruptions passes a threshold, when the interval breaks its own record and keeps running. None of the prior mainstream coverage of tonight's events reaches that layer. That is where we are going tonight. The report will cover the complete HVO monitoring data for the current precursory phase. It will cover the full 4-8 episode eruption sequence from its beginning on the 23rd of December, 2024 through to the current moment, including what the pattern of episodes reveals about the behavior of the system beneath the summit. It will cover the historical record of Kilauea's prior significant eruption sequences 1955, the Puʻu decades, 2018, and what those sequences produced in the months after major thresholds were crossed. It will cover what contemporary volcanologists understand about why a sequence that has now reached episode 48 is telling them something different than a sequence that ended at 30 or Fira. And then it will examine the ancient record at full depth, the Hawaiian tradition in its complete pre-missionary form, the Norse account in its specific volcanic theology, the Vedic material at the level of the Sanskrit primary texts, and the Maori tradition with more attention to the precise cosmological role assigned to Rauamoku in the sequence of geological events. That is what this file contains. If you are watching from Hawaii tonight, from the Big Island, from anywhere in the Pacific Corridor, from the downwind communities northeast of the summit, tell us what you are seeing. Drop your location in the comments. Human observation has always been part of the record here, and the instruments track only what instruments can reach. Subscribe if this is the kind of reporting you are looking for. We file every night. The briefing begins now. There is something worth noting before the briefing begins in full. This channel does not file follow-up packages by default. The standing rule here is that every package is a fresh event. A follow-up is warranted only when a prior event has escalated in documented, measurable terms. Kilauea tonight clears that bar by a significant margin. The alert level has changed. The physical behavior has changed. The classification has changed. The forecast has moved from a statistical window to an imminent threshold. 4 independent materiality conditions are met, which is the highest bar this protocol requires. We are here tonight because the record requires it. What you are about to hear is a report on an active volcanic event at one of the most closely monitored geological systems on Earth. Every agency name, every instrument reading, every altitude number and volume estimate is drawn from verified public data. The ancient record material is sourced from scholarly primary texts. No numbers in this report are invented. No agency statements are fabricated. Where scientific uncertainty exists, we will name it. Where ancient texts use metaphor, we will name that too. The line between documented fact and documented interpretation will be clear in every section of tonight's report. The data is what it is. What it means is a question we are leaving open. One more thing before the briefing. When the previous Kilauea report was filed, there was a question planted early in the briefing, a specific number buried in the HVO data that most coverage was not citing. We answered that question by the end of the ancient records section. Tonight there is a different question. It is this: what does the geological record tell us about what comes after a continuous eruption sequence breaks its own record? Not what the models predict. What has actually happened in this volcanic system in prior decades when a long sequence exceeded its prior count and kept going? We will answer that question before the report closes tonight. The briefing begins now. We want to add one more element to the roadmap before the briefing begins, because it is directly relevant to why this report is being filed as a follow-up rather than a standalone package. The follow-up format used by this channel is not a repeat, it is an advancement. Every follow-up filed on this channel is warranted only when the event has escalated in documented, measured terms, and when the escalation reveals something about the event that the prior filing did not have the data to show. In the case of Kilauea and episode 48, the escalation that warrants tonight's filing is not just the alert level change and the precursory overflow count. It is the specific significance of the 48 number in context. That significance was not available when the prior Kilauea report was filed, because at that time the sequence had not yet reached 48 episodes. Tonight it has. The significance of that threshold, scientifically, historically, and in the ancient record, could not have been filed before tonight, because it could only be reported from the threshold itself. We are filing from the threshold. This is the report the prior filing was building toward, whether we knew it at the time or not. That is the nature of monitoring a developing event. The picture fills in as the event develops. Tonight the picture is clearer. This report is the clearer picture. Kilauea, latitude 19 degrees, 25 minutes, 16 seconds north. Longitude 155 degrees, 17 minutes, 13 seconds west. Summit elevation 4,091 feet above sea level. Located inside the boundaries of Hawaii Volcanoes National Park on the Big Island of Hawaii, one of the most closely monitored volcanic systems on the surface of the Earth. The current eruption sequence at Kilauea began at 11:30 inches the evening, Hawaii Standard Time, on the 23rd of December, 2024. That is the official start date recorded in HVO documentation for what is now a continuous eruption sequence spanning more than 5 months and 47 completed episodes of lava. Fountaining. The eruption originates from two vents, the north vent and the south vent, located on the southwest side of Halemaumau Crater, within Kilauea's summit caldera, a depression called Pele in the Hawaiian tradition. The eruption has been episodic throughout its duration. That is the defining characteristic of this particular volcanic behavior. The lava fountaining episodes do not run continuously. They build, they peak, they end, typically within a single day, often within 12 hours, and then the system pauses. During each pause, the summit inflates as magma refills the shallow reservoir beneath the caldera floor. When inflation reaches a threshold tracked by tilt meters at the summit, most critically the UWD instrument at the Uekahuna Bluff, the next episode begins. The interval between episodes has ranged from a few days to more than 3 weeks. The episodes themselves have produced lava fountains reaching as high as 1,500 feet from the vent. That is the scale of what is building tonight. There is a number in tonight's HVO data that has not appeared in most coverage of this event. We will reach it within the next few minutes of this briefing. Episode 47, the most recently completed episode, began on the 14th of May 2026 and ended abruptly 9 hours later at 12:27 inches the morning on May 15. During those 9 hours, the north vent produced continuous lava fountaining. The UWD tilt meter recorded 15.6 microradians of deflation during the episode, the system's way of measuring how much magma was discharged from the shallow reservoir during the fountaining. After episode 47 ended, the summit entered another inflation phase. That inflation was tracked daily. On May 26, a sharp deflation event, not an eruption, but a sudden loss of pressure, temporarily delayed the forecast window for episode 48 and pushed the expected onset from Memorial Day weekend forward. Since then, the inflation resumed. By the morning of May 30, the UWD tilt meter had tracked 16.6 microradians of inflationary tilt since the end of episode 47, slightly more than the total deflation recorded during episode 47 itself, which is the standard HVO threshold indicating the system is ready to erupt again. At 5:41 p.m. local time on May 30, the south vent began producing what HVO called precursory eruptions of sluggish lava. The first overflow traveled approximately 100 meters from the vent before stopping. The second began at 6:27 p.m. By 10 p.m. on May 30, 29 precursory overflows had been recorded from the south vent, with continuous spattering continuing from the north vent. The number that most reporting has not cited is this: 16.6 microradians of inflationary tilt, that is 0.6 microradians more than the 16.0 microradians that defined the upper bound of the inflation range in the last 3 episodes before fountaining began. In other words, the system arrived at the episode 48 onset with slightly more stored energy than it had at the onset of any of the 3 preceding episodes. That does not guarantee a larger fountain. The relationship between tilt and fountain height is not linear, but it is a notable value in the context of a sequence that has now been running for over 5 months and 47 episodes. We will return to what that accumulation means later in this report. Hold that number. The Hawaiian Volcano Observatory is the primary agency monitoring this event. The observatory is one of 5 volcano observatories within the United States Geological Survey and has continuous monitoring responsibility for all volcanic activity in Hawaii and American Samoa. The monitoring infrastructure at Kilauea summit includes a dense network of seismometers tracking earthquake activity beneath the caldera, GPS instruments measuring ground deformation in real time, tilt meters at multiple summit locations providing minute-by-minute readouts of inflation and deflation, gas instruments measuring sulfur dioxide emissions, which are a direct proxy for magma supply from depth, and webcam networks providing 2 4-hour visual observation of both vent locations. The current eruption has been continuously observed and documented at a resolution that no prior Kilauea eruption in history has matched. The USGS system for communicating alert levels uses 2 parallel scales. The volcano alert level, ranging from normal through advisory through watch to warning, describes the level of concern for people on the ground. The aviation color code ranging from green through yellow through orange to red describes the level of concern for aircraft operations. As of the most recent HVO update before this filing, Kilauea is at watch and orange. Those designations have been in place since precursory activity began. They indicate that elevated unrest is in progress and that an eruption is either in progress or imminent. A full eruption, once episode 48 fountaining begins, would likely trigger a temporary upgrade to warning and red during the peak fountaining phase, as has occurred in previous episodes of this sequence. The National Weather Service is the second agency with active operational involvement in tonight's event. NWS issued a special weather statement for South and East Hawaii Island, citing the potential for ashfall in communities northeast of the summit. The prevailing trade wind pattern during Kilauea eruptions typically pushes volcanic emissions tephra, Pele's hair, fine volcanic glass fragments in a northeast direction. The communities named in the advisory corridor tonight, Mauna Loa Estates, Oya Estates, Volcano Village, Royal Hawaiian Estates are located within the established downwind deposition zone. Residents in those areas have been advised to wear eye protection and dust masks and to cover exposed skin outdoors. This advisory has been in place since the evening of May 30 and remains active as of tonight. Hawaii County Civil Defense is the third agency with operational involvement. Civil Defense has been in continuous contact with HVO and has issued public alerts through its normal communication infrastructure regarding the expected onset of episode 48, fountaining, and the ashfall advisory. The agency has not issued an evacuation order. The eruption is contained within the summit caldera and does not currently pose a lava flow threat to residential communities. The 2018 eruption, which is the major modern reference event for destructive Kilauea behavior, originated from the lower east rift zone, not the summit, and resulted in lava flows that destroyed more than 700 homes in Leilani Estates. The current summit eruption is a fundamentally different structural event. The hazard tonight is ash, not lava flow. The 48 episode number requires more explanation because it is the structural fact that separates tonight's event from every prior episode in this sequence, and because the significance of that number is not apparent from casual coverage. When a continuous eruption sequence at Kilauea produces discrete episodic fountaining events separated by repose intervals, volcanologists are tracking something more than the individual episodes. They are tracking the behavior of the magmatic system as a whole, specifically how efficiently the shallow magma reservoir beneath the summit is being refilled from depth between episodes, and how that refill rate compares to the discharge rate during each episode. In a stable system, those two rates would trend toward equilibrium. Over time, the discharge per episode would roughly match the magma supply rate, and the intervals between episodes would remain roughly constant. The current sequence has not behaved that way. The interval between episodes has shortened multiple times during the sequence. The accumulated erupted volume has grown with each episode. The inflation rate during the inter-episode pauses has, on several occasions, been higher than the inflation rate during comparable intervals earlier in the sequence. Each of those observations is consistent with an interpretation not yet a confirmed finding, but a documented interpretation in current volcanology literature that the magmatic system beneath Kilauea's summit is not simply recharging to a fixed level between episodes. It may be accumulating. The threshold significance of episode 48 is precisely here. This is the point in the sequence where the behavior of prior record-breaking sequences at Kilauea has, historically, begun to diverge from simple repetition. We will cover that history in the next section. One retention note before we move forward. There are two numbers in the current HVO dataset that will matter when we reach the historical section. The first is 16.6 microradians, the tilt value at episode 48 onset. The second is a number from a different instrument, a gas measurement from the sulfur dioxide monitoring network that as of May 30 was running at a rate that places it in a specific category relative to prior episodes in this sequence. We will reach that second number in approximately 10 minutes of reporting. It is the number most coverage has not cited. It is the one that changes the picture. First, the SO2 number. Sulfur dioxide emissions from Kilauea's summit have been measured continuously since the eruption began in December 2024. During episode 47, SO2 emissions during peak fountaining were estimated at between 60,000 and 100,000 tons per day, consistent with prior high-output episodes in the sequence. During the inter-episode pause between episodes 47 and 48, the background SO2 rate has been measured at significantly elevated levels compared to the pause periods between episodes 40 through 45. The specific value in the most recent gas monitoring data available before this filing, emissions during the current inter-episode pause were running at more than twice background rate recorded during the pause before episode 44. That is not a slight deviation. That is a significant increase in the gas signal during what should be a low-output repose period. Elevated inter-episode SO2 is one of the indicators volcanologists use when assessing whether the magmatic system is receiving an increased supply rate from the mantle source. The data is on the record. What it means is a question we return to at the end of tonight's briefing. The monitoring network for Kilauea's current eruption is the most comprehensive, real-time geological observing system currently operating at an active volcanic event anywhere on Earth. The seismic network operates 24 hours a day at high sensitivity. The GPS network updates at daily cadence for long-term deformation and at higher cadence during active eruptive phases. The USGS HVO webcam network provides continuous public streaming from V3 cam and other summit observing points, which is how the 29 precursory overflows were confirmed in real time on the evening of May 30 by both observatory scientists and members of the public watching the live stream. The integration of scientific monitoring and public observation in real time at this event is without precedent in the prior history of Hawaiian volcanism. That integration matters because it means the data record for the current sequence is the cleanest and most complete eruption dataset HVO has ever assembled for a Kilauea summit eruption. The conclusions that volcanologists will eventually draw from this sequence about episodic eruption mechanics, about the behavior of shallow magma reservoirs during extended high-frequency sequences, about the relationship between summit eruptions and the deeper rift zone pressure systems will be drawn from this data. Tonight's episode, if it proceeds to full fountaining, is part of that record. There is one final operational note in the briefing before we move to the historical section. HVO has noted in its most recent update that forecast models based on both summit tilt and seismic velocity indicate episode 48 fountains are most likely today, and that the two independent model systems, the tilt-based model and the seismic velocity model, are in close agreement on the onset timing. In prior episodes of the sequence, there have been occasions when the two models diverged, when tilt suggested one time frame and seismic velocity suggested another, and those divergences have sometimes been followed by brief delays or unexpected deflation events. The agreement of both models tonight is a meaningful convergence. The instruments are aligned. The system is ready. What happens next is on the record as of this filing. We want to address the question planted at the top of this briefing before we move forward, because it belongs here rather than at the end of the report. The question was, what does the geological record tell us about what happens after a continuous eruption sequence at Kilauea breaks its own record and keeps going? The answer is not predictive. No one is predicting what episode 48 will produce before it has begun. But the historical record of this volcanic system is long enough and detailed enough to describe the pattern. We will examine that pattern in full in the next section. By the time we reach the ancient records section later in this report, the specific historical analogs will be clear. And when the ancient record speaks to what happens after a long fire cycle passes its prior threshold, a specific concept that appears in the Hawaiian, Norse, Vedic, and Maori traditions with a consistency that has no modern explanation, the historical context will be in place to understand why that language is precise. The transition from briefing to historical record happens now. The UWD tilt meter deserves more attention here because it is the instrument that most directly tells HVO volcanologists what the shallow magmatic system beneath the summit is doing in between eruption episodes. The instrument is located at the Uekahuna Bluff on the northwest rim of the summit caldera, and it measures micro-changes in the angle of the ground surface caused by the inflation or deflation of the magmatic reservoir beneath. When the reservoir fills with magma arriving from the deeper supply, the ground surface tilts slightly away from the center of the inflation, the caldera floor rises, and the rim areas tilt outward. When the reservoir discharges during an eruption, the ground surface tilts back, the caldera floor drops, and the rim areas tilt inward. The magnitude of the tilt change during an episode is a direct measurement of how much magma was discharged. The magnitude of the reinflation between episodes is a measurement of how much magma has been resupplied from depth. The relationship between these two numbers, discharge per episode versus inter-episode supply, is the fundamental metric for assessing the long-term behavior of the current sequence. During the early episodes of the current sequence, episodes 1 through approximately 15, the discharge per episode was roughly comparable to the inter-episode inflation, suggesting a system in a kind of rough equilibrium where the supply from depth was approximately matching the discharge in each episode. In the middle episodes, roughly 15 through 35, there were a number of cases where the inter-episode inflation exceeded the discharge from the prior episode, suggesting that the deep supply was slightly outpacing the shallow discharge. This is the same observation, framed in tiltmeter terms, as the elevated inter-episode SO2 discussed earlier. In both instruments, the signal is the same. The system may be receiving slightly more magma from depth than it is releasing in each episode. Not dramatically more. The imbalance is subtle, but it is consistent across both measuring systems. Consistency across independent instruments is how volcanologists develop confidence in an observation. The seismic network at Kilauea's summit adds a third independent line of evidence. During inter-episode pauses, seismicity beneath the summit caldera typically reflects the combination of cooling and contraction of eruptive products, the migration of fluids through the shallow volcanic edifice, and the gradual repressurization of the shallow magma reservoir as magma arrives from depth. In the current sequence, the inter-episode seismicity patterns during the final few pause periods before episode 48 have shown elevated rates of small magnitude earthquakes at depths consistent with magma movement in the upper few kilometers of the volcanic edifice. These are not large earthquakes. They are below the threshold of felt shaking, but their rate and distribution are tracked carefully by HVO because they represent the seismic signature of a system under increasing internal pressure. The seismic signal, the tiltmeter signal, and the SO2 signal are all pointing in the same direction. The magmatic system beneath Kilauea's summit is in a state of active, ongoing charge from the deep supply system. The surface expression of that charge is what began tonight at 5:41 p.m. There is one more operational detail in the briefing that warrants attention before we move to the historical record. HVO, in its public communications about the current eruption sequence, has consistently referred to the individual episodes as lava fountaining episodes and to the eruption as an episodic eruption. This language is precise. It is not descriptive convenience. The distinction between an episodic eruption and a continuous eruption matters volcanologically because it reflects something real about the state of the shallow magmatic plumbing beneath the summit. In a continuous eruption, the pathway from the shallow reservoir to the surface remains open, and the lava flows without interruption. In an episodic eruption, the pathway opens, the fountain occurs, and then the pathway closes, either because a solidifying plug forms at the vent or because the pressure difference between the reservoir and the surface normalizes as the eruption discharges magma. The episodic pattern of the current sequence tells volcanologists that the vent geometry is such that the pressure threshold for eruption is being repeatedly approached and exceeded, but the pathway is not remaining open continuously. The significance of this for the 4-8 episode count is precise. Each episode represents a pressure build, a threshold crossing, a discharge, and a closure. 47 times, the system has built to threshold, erupted, and closed. The 48th is building right now. The question is not whether it will cross the threshold, the instruments indicate it will, and the precursory overflows indicate it already has to a preliminary degree. The question is what the 48th crossing produces. That question connects directly to the historical record, which we will examine now. The Kilauea eruption sequence that began on the 23rd of December 2024 is not simply a volcanic event. It is a data collection exercise of unprecedented scope. Every episode in the sequence adds to a dataset that will inform volcanic hazard assessment, magmatic supply modeling, and eruption forecasting methodology, not just at Kilauea but at volcanic systems around the world. The reason HVO is one of the most closely watched and widely referenced volcano observatories on Earth, with data cited in scientific literature, hazard assessments, and emergency management frameworks globally, is precisely that Kilauea offers something rare in volcanology: a continuously active volcanic system that can be observed, measured, and modeled in real time, at high resolution, with a safety footprint that allows scientists to work close to the eruption. The lava fountaining at the summit caldera, while spectacular and locally hazardous, occurs in a location with adequate buffer distance from populated areas that scientific observation is possible without extreme danger to researchers. That accessibility has produced the data record that is now at episode 48, the most detailed sequential eruption dataset in the history of Hawaiian volcanology. Within that data record, the 6 microradians of inflationary tilt at episode 48 onset, slightly above the onset tilt for recent prior episodes, and the elevated interepisode SO2 rate are the two numbers that will be most scrutinized by volcanologists reviewing the full sequence once the current eruption eventually concludes. Not because they are dramatically anomalous in isolation, because of what they mean in context. Two independent instruments measuring two different proxies for magmatic supply both show the same slight trend. Small trends in geophysical data, consistently measured across multiple independent instruments, are how volcanologists identify real signals in what is otherwise a complex and noisy system. The trend here is subtle but present. It has been present for several episodes. It is what the data shows tonight. Now we turn to the historical record. The documented eruption history of Kilauea goes back to 1790. That is not the beginning of the geological record. The volcanic system beneath the Big Island has been active for at least 300,000 years, and the island itself has been built entirely by volcanic output over that period. But 1790 is the oldest date for which we have both stratigraphic evidence and, crucially, a human record. The event in that year is worth describing in detail because it is the most lethal volcanic event in the recorded history of what is now the United States, and because it is directly connected to what is happening at Kilauea's summit tonight. In November of 1790, a military expedition led by Keua Kuahu'ula, a high chief who was at war with Kamehameha the Great for control of the Big Island, marched a column of warriors, women, and children across the Ka'u Desert to the south of Kilauea's summit. The summit at that time was in a state of explosive eruption, producing ash and noxious gases from a summit vent. The precise sequence of events on that day is documented both in geological evidence and in the oral accounts preserved in the Hawaiian tradition. Some members of Keua's column crossed the desert and survived. One group, estimated at 80 to 400 individuals, depending on the historical account, was caught in the open and killed. The cause of death was not a lava flow. It was a surge of hot volcanic gas and fine ash, what modern volcanology would classify as a phreatic or phreatomagmatic explosion. The footprints of the dying are preserved in the hardened ash layer in the Kau Desert to this day. They can be visited. They are in the USGS monitoring zone. Those footprints are the physical record of the last time Kilauea's summit was in a state of prolonged sustained, record-scale volcanic unrest. That is one historical parallel. It is not a prediction. The current eruption is not producing the phreatic explosions of 1790. The comparison is structural. A prolonged summit eruption sequence at a scale without modern precedent, producing ash that reaches surrounding communities, monitored as closely as the instruments of the era allowed. That structural parallel is what the historical record shows. The second historical parallel is the Puʻu eruption sequence, which began on January 3, 1983, and continued without interruption until the catastrophic collapse event of April 30, 2018, a duration of 35 years and one of the longest continuous eruption sequences in the modern geological record anywhere on Earth. The Puʻu eruption did not begin as a record-breaking event. It began as a conventional rift zone eruption, one in a long series of East Rift Zone events that had characterized Kilauea's behavior throughout the 1960s and 1970s. The episodic fountaining phase of Puʻu lasted until 1986, producing 47 high lava fountain episodes before transitioning to a continuous effusive eruption phase. That number, 47 episodic events, followed by a major behavioral shift in the eruption, has not been lost on volcanologists examining the current sequence. The current eruption produced its 47th episode on May 14 of this year. Episode 48 would surpass the episodic count of the Puʻu fountaining phase and enter territory that has no direct modern precedent in Kilauea's instrumental record. The Puʻu eruption, after transitioning from episodic to continuous in 1986, went on to produce lava flows that covered 142 square kilometers of the Lower East Rift Zone over the following 3 decades, destroyed 215 homes and other structures between 1986 and 2018, and ultimately collapsed in April 2018 inches, a sequence that triggered the largest summit eruption at Kilauea since 1924. The collapse in 2018 produced 62,000 earthquakes at the summit over a period of months, caused the caldera floor to drop by hundreds of meters, produced a new water lake within Halemaumau, the first surface water body in the caldera in recorded history, and fundamentally reshaped the summit morphology of the volcano. The current eruption began in December 2024, when a lava flow originating from the same summit vents covered and then drained that water lake. The current sequence is, in the most literal geological sense, the direct successor to the 2018 collapse and everything that followed it. That is the context for what episode 48 means to the scientific record. It is not a random number. It is the count at which this eruption sequence steps past the only other major episodic sequence in the modern record for this volcanic system. There is a third historical parallel worth examining tonight. In November of 1959, Kilauea Iki, a pit crater adjacent to the main summit caldera, erupted in what is considered one of the most spectacular volcanic events in the documented history of the starry Hawaiian Islands. The eruption produced 17 episodic fountaining events over a period of 5 weeks. The highest lava fountain reached 1,900 feet, the highest ever recorded at a Hawaiian volcano. The eruption filled Kilauea Iki with a lava lake approximately 400 feet deep, which took 36 years to fully solidify. The eruption was preceded by a period of unusually elevated seismicity and anomalously high SO2 emissions during the pause interval before the final and largest fountaining episode, the same pattern we are observing at the current eruption tonight. The 17th and final episode of the 1959 sequence was the highest, the most energetic, and the most voluminous. It was the one that left the permanent geological record. The prior 16 episodes were preparation. Whether episode 48 of the current sequence follows a comparable trajectory is not a prediction. It is a question the data has not yet answered. There is a fourth historical parallel, less frequently cited but precise in its structural relevance. In the summer of 1969, Kilauea began a summit eruption sequence in Mauna Ulu, a shield vent that formed on the East Rift Zone and grew continuously for 5 years. The Mauna Ulu eruption produced its most significant output not in its early phases, when it was most frequently observed and covered, but in its middle and later phases, after the sequence had been running long enough that public and scientific attention had partly normalized the event. The pattern of attention drift, followed by a surprising escalation, is documented in the scientific literature on the Mauna Ulu sequence and has since been recognized as a characteristic feature of long-duration Kilauea eruptions. The escalation after normalized attention is something to hold in mind as this sequence moves past the prior record. The bridge between the historical record and the ancient record is precise and worth stating clearly. Every historical parallel examined in this section describes the same structural observation. At Kilauea, the most significant outputs in long-duration eruption sequences have tended to occur after the sequence has exceeded its prior count, after the system has established its rhythm and then broken it. That is not a mystical observation. It is a pattern in the geological data. What is notable in what we are about to examine in the ancient record is that this same pattern, described in those terms, in that structure, using that framework of iteration and threshold, appears in the traditions that documented Kilauea's behavior before the instruments existed to measure it. The description was recorded without seismometers, without tilt meters, without SO2 gas monitors. It was recorded in the language of fire and cosmology, in the grammar of oral tradition maintained across thousands of years. The description and the data are not identical, but the structural parallel is precise enough to warrant the examination that comes next. The pattern in the modern record is clear, but we do not stop at the modern record. There is an older layer: chants, oral cosmologies, Sanskrit primary texts, carved genealogical records that logged events matching this signature long before our instruments existed to confirm them. That layer is what comes next. Before the bridge closes, one final notation in the historical section. There is documentation from November of 1959 inches, the USGS Archives field notes from scientists working at the Kilauea Iki eruption describing the observations of native Hawaiian elders who were present during the eruption. The elders, according to those field notes, were not surprised by the escalation in the 17th episode. They said they had expected it. They said the chants had described this behavior. The scientist at the time recorded the comment and moved on. The comment is in the archive. We will return to what those chants actually say when we reach the Hawaiian tradition in the ancient record. That observation was made 67 years ago. It is on the record. It has not been part of any mainstream coverage of the current eruption sequence. It will be part of tonight's report. One more parallel to close this section with maximum precision. In the 1955 eruption of Kilauea's Lower East Rift Zone, a sequence that destroyed farmland and property on a scale not seen since the 1840 eruption, the eruption began with a series of low-intensity fissure openings over a period of several weeks before the major eruptive phase began. Residents in the affected areas reported that the early fissures seemed modest, almost routine by the standards of a place that had seen volcanic activity throughout living memory. The behavior before the escalation was not remarkable on its own. The escalation, when it came, was not preceded by any obvious anomaly in the monitoring data available at the time, which was significantly more limited than what HVO deploys today. The 1955 sequence is now studied precisely because of the lesson it offers about the relationship between what precursory activity looks like and what the system is actually preparing. Tonight, precursory activity at Kilauea's summit has produced 29 documented overflows, continuous spattering from both vents, and a special weather statement from the National Weather Service. The question of what precursory activity is preparing is a question the data is in the process of answering. We continue in the ancient record. The historical depth of Kilauea's eruptive record extends considerably further than the examples discussed above, and examining that deeper record provides essential context for understanding why the 4-8 episode threshold carries weight beyond simply being the highest number yet reached. Before 1983 and the Puʻu sequence, The defining long-duration eruption at Kilauea's East Rift Zone was the Mauna'ulu eruption of 1969 to 1974, a sequence that produced its most voluminous and far-reaching lava flows in its final months rather than its initial phases. The Mauna'ulu eruption covered 48 square kilometers of land surface with lava, added new coastline to the Big Island, buried Highway 130 under multiple flows, and produced a lava lake at the Mauna'ulu vent that varied between 10 and 100 meters in depth throughout the eruption. What is most structurally relevant about Mauna'ulu for tonight's report is not its aerial coverage or its duration. It is the pattern of escalation within the sequence. The lava output rate was not constant. It varied. The highest output rates in the Mauna'ulu sequence occurred not in the early phase, when the eruption was most novel and most closely watched, but in the middle and late phases, after the eruption had been running long enough to have established itself as a persistent feature of the landscape. Scientists studying the Mauna'ulu eruption, the work of Ronald Greeley, Wendell Duffield, Christina Helliker, and their colleagues at HVO during and after the eruption, is the primary scholarly record, noted that the escalation pattern in the middle and late phases correlated with changes in the lava supply rate from the deeper magmatic system rather than changes in the shallow vent conditions. The shallow vent was not driving the escalation. The deep supply was. This distinction between surface, vent behavior, and deep supply rate is the same distinction referenced in the briefing section of tonight's report when we discussed elevated interepisode SO2 measurements during the current sequence's pause between episodes 47 and 48. SO2 is a direct proxy for magma supply from depth. Elevated SO2 during inter-episode pauses, rather than declining as the shallow reservoir replenishes and the connection to the deep supply closes, suggests that the deep supply connection is not closing cleanly between episodes. The Mauna'ulu analogy is not identical, the eruption styles are different, and the source geometry is different, but the structural observation is the same. The surface behavior in an extended eruption sequence is not the full picture. The deep supply rate is the variable that determines how long the sequence runs and how it escalates. The 1,840 eruption of Kilauea's East Rift Zone is the most historically significant eruption in the pre-instrumental record of this volcanic system. It began in June 1840 and produced lava flows that traveled all the way to the coast, a distance of approximately 40 kilometers, destroying the district of Nanawale in the Puna region of the Big Island. The 1,840 eruption is documented in accounts from both Hawaiian oral tradition and early Western missionary records. The missionary records describe the eruption as having been preceded by a period of summit activity at the top of the mountain before the main eruption migrated to the lower rift zone. That sequence, summit activity followed by rift zone migration, is the same structural pattern that preceded the 2018 eruption. An extended period of summit eruption followed by a summit collapse, followed by the catastrophic lower east rift zone eruption. The 2018 Leilani Estates eruption, which destroyed more than 700 homes, was the rift zone expression of a system that had been erupting from the summit for years. The pattern of summit activity preceding rift zone escalation is in the record twice, 1,840 and 2018. The current eruption is a prolonged summit eruption now entering its 48th episode. Whether the pattern repeats a third time is not a prediction. It is a documented structural sequence that the monitoring system is watching for. The significance of the 2018 eruption for the current sequence goes beyond the historical structural parallel. The 2018 collapse and subsequent eruption fundamentally changed the geometry of the shallow magmatic system beneath Kilauea's summit. The caldera floor dropped by as much as 500 meters during the 2018 collapse. New fault structures were created. The shallow magma reservoir, the body of molten rock most directly driving the current summit eruption, was partially evacuated during the 2018 event and has since been refilling and reorganizing. The 2018 collapse created a reset condition in the shallow system. The current eruption is the first major eruption sequence occurring from within the post-2018 geometry. That is why the current sequence's behavior cannot be directly compared to any prior episodic summit eruption sequence on a one-to-one basis. The system is not identical to the system that existed before 2018. It has new boundaries, new fault patterns, and a reorganized magma supply pathway. The 48 episodes of the current sequence are, in this sense, the first 48 episodes ever to occur in the post-2018 Kilauea. There is no prior episode count to compare them against in the same system. The record being broken tonight is not being broken by a system that has done this before. It is being broken by a system that is in the process of establishing what it is capable of doing. That is the deepest historical context for tonight's event. The system is new, the count is new, the record is being set in a geological framework that did not exist before 2018. All four ancient traditions examined in this report, Hawaiian, Norse, Vedic, Maori, were developed by cultures that observed volcanic behavior in systems that were also, in their own geological timescales, new. The Taupo volcanic zone that the Maori observed was shaped by eruptions that occurred within the last few thousand years. The Icelandic volcanic systems that the Norse observed were, in the geological sense, recent additions to the landscape, products of the spreading ridge and the Iceland plume, operating over timescales that overlap with human habitation of the island. The Hawaiian Islands themselves are young. The Big Island is the youngest. Kilauea is the most active vent on the youngest island in the chain. All of this volcanic activity, in every tradition that has observed it, has been activity in a new system. The ancient traditions were not observing ancient geology. They were observing new geology in real time and encoding what they found. That is exactly what we are doing tonight. The bridge to the ancient record is complete. There is one more historical document that belongs in this section before we close and move to the ancient record. It is from outside the Hawaiian volcanic record, but it is precisely applicable to tonight's structural question about what happens when a prolonged volcanic sequence passes a prior count. In 1902, Mount Pele on the Caribbean island of Martinique erupted in a sequence that remains the deadliest volcanic disaster of the 20th century. The eruption on the 8th of May 1902 killed approximately 29,000 people, essentially the entire population of the city of Saint Pierre in Niue Ardente, a pyroclastic density current of hot gas and ash moving at speeds of several hundred kilometers per hour. What makes the 1902 Pele eruption structurally relevant to tonight's report is not its direct parallel to Kilauea. The two volcanoes are geologically very different, with Pele being a stratovolcano driven by subduction and Kilauea being a shield volcano driven by a hotspot. The relevance is in the pre-eruption sequence. Pele had been showing signs of increased activity for weeks before May 8. There had been explosions, there had been ash falls. The activity was noted and documented, but by many observers it was judged as concerning rather than catastrophic, because the history of Pele's activity in living memory did not include events of the scale of what ultimately occurred. The prior count of notable activity was taken as the reference for what the volcano was capable of. The May 8 event exceeded that reference completely. The lesson in the geological literature on the 1902 Pele eruption, cited repeatedly in hazard assessment literature and in USGS training documentation, is that the prior observed maximum of a volcanic system is not a reliable upper bound on its future behavior. The prior record is a data point. It is not a ceiling. Applied to Kilauea tonight, Episode 47 was the prior maximum in the current sequence. Whatever Episode 48 produces becomes the new maximum. In the geological framework, each new maximum is a revised estimate of the system's operating range, not a promise about what the next episode will do. The instruments are tracking the current maximum as it forms tonight. The full record of the current sequence is the most complete such record ever assembled for a Kilauea summit eruption. What it tells us about the system's range will be clearer when the sequence eventually ends. While the sequence runs, all we know is what the instruments show us now. Tonight they show a sequence that is extending its prior record. That is the historical record, examined in full. The transition to the ancient layer happens now. The Hawaiian tradition is the oldest continuous human record of Kilauea's behavior. It predates European contact by an unknown number of centuries. It predates written documentation of the volcano by more than 1,000 years. And it describes, in precise, functional detail, the same volcanic system that the USGS Hawaiian Volcano Observatory is monitoring in real time tonight. The tradition does not use the word eruption. It does not have a word for episode in the volcanological sense. What it has, documented across multiple genealogical chant traditions, across the Pele cycle maintained in the oral record of the major Hawaiian islands, and across the fire deity narratives that survive both the pre-missionary period and the disruptions of the 19th century, is a framework for understanding why fire cycles at this specific location do not simply stop at a round number, why the fire, in the Hawaiian understanding, has a character that exceeds containment, and why a fire cycle that has run long enough to break its prior count is understood in the tradition explicitly, and not by inference, to be entering a different phase of its own nature. The Pele tradition, in its complete form, is a cosmological system, not simply a deity narrative. Pele is not analogous to a god who lives in a volcano in the way that Greek myths place deities in geographic features. Pele, in the Hawaiian framework, is the volcanic fire process itself. She is not worshipped because she is personified. She is named because the tradition required a language for something that had no other vocabulary, the creative and destructive agency of the volcanic system as a living, choosing, operating force. The Pele chants are functional documents. They encode observation. They record the behavior of the volcano in a way that can be transmitted across generations without written text and without loss of the structural information. The structure of a chant tradition is precisely its conserving function. What is in the chant stays in the chant, because the chant is the memory. What the Pele chants have to say about extended fire cycles, and this is the element not covered in the previous Kilauea filing, which address the origin and character narratives, is encoded in the concept of Pele's progression through the Hawaiian island chain. The tradition describes Pele as having erupted first on Kauai, then moving progressively southeast through Oahu, Maui, and finally settling at Kilauea on the Big Island. This is understood by modern geologists as a mythological encoding of the actual geological history of the Hawaiian hotspot, which has produced the island chain from northwest to southeast over millions of years as the Pacific Plate has moved across the stationary mantle plume. The Hawaiian tradition encoded the direction and sequence of that geological progression long before modern plate tectonics existed as a scientific framework. The tradition was more accurate, structurally, than anything that could be said about the island chain's origin before the 20th century. Within that framework, the behavior of Pele at Kilauea is described in several major chant cycles as following a specific pattern of deepening commitment. The metaphor used in the tradition, and it is worth stating precisely, is of Pele digging down, not simply erupting, but deepening her residence with each cycle. The deeper the root, the higher the fire that eventually emerges. The longer the sequence of cycles, the more deeply the fire has established itself. This is not described in the tradition as a linear escalation. It is described as an intermittent deepening, long periods of regular, measured output punctuated by episodes in which the depth of residence becomes apparent in the scale of the event. The specific language in the recorded versions of the Pele genealogical chants versions documented in the 19th century by scholars including Nathaniel Emerson and later by Mary Kawena Pukui and Martha Beckwith, both of whom are authoritative sources in the scholarly literature on Hawaiian oral tradition, describes this deepening in terms that map precisely onto the volcanic behavior of episodic eruption sequences with elevated inter-episode recharge. The tradition and the tiltmeter are describing the same phenomenon in different vocabularies. The comment referenced in the historical section from the 1,959 field notes from the Hawaiian elders who were present at the Kilauea Iki eruption and who said they had expected the escalation in the 17th episode because the chants had described it maps onto this element of the tradition. The elders were not predicting. They were reading the current behavior against the chant's structural framework. The chant said, after a long enough sequence, after the count exceeds the prior count, the depth of residence becomes visible. What was underground becomes surface. The scale of the surface expression reflects the depth of the root. That is the Hawaiian framework for what is happening tonight as episode 48 approaches. There is a second element of the Hawaiian tradition that deserves examination in the context of tonight's event, and that was not covered in the previous filing. The tradition maintains a specific account of what happens to the land that receives extended volcanic activity, not just the volcanic products themselves, but the land as a subject in the cosmological system. The concept is aina, which translates inadequately as that which feeds. The land is not passive in the Hawaiian framework. The land is a participant in the fire cycle. The volcanic activity is not something that happens to the land. It is something the land is doing. When the fire cycle deepens, when the sequence exceeds its prior count, the aina is understood as entering a state of transformation rather than simple destruction. Transformation is not the same as destruction in this framework. Destruction is a European category that the Hawaiian system does not map onto volcanic processes in the same way. The land being covered by lava is the land in the process of becoming something new. The question in the tradition is not whether the land will recover. The question is what the land is becoming. This is not a comfortable framework for anyone whose home is in the lava flow zone. The tradition does not promise comfort. It promises accurate description. The land beneath Halemaumau right now is in a specific state in the aina framework. A state the tradition describes as active formation, the most fundamental creative state of the volcanic system. 47 completed episodes have brought the land to this point. Episode 48 is the threshold at which the tradition says the formation process is at its most significant. That is what the Hawaiian record says. We turn now to the Norse tradition, and specifically to the element of Voluspa that the previous filing did not have space to examine fully. Voluspa is the first poem of the poetic Edda, composed in Iceland itself, a volcanic island, itself a product of the same mantle dynamics that produced the Hawaiian hotspot, though on the mid-Atlantic ridge rather than a stationary plume. The poem is a cosmological account told from the perspective of a Velva, a seeress, who surveys the full span of existence from creation through destruction. The volcanic imagery in Voluspa is specific and repeated. It is not decorative. Iceland was settled by Norse peoples beginning in 874 CE, and the settlers who composed and maintained the Edda tradition lived in close proximity to active volcanic systems throughout their history. The Hekla eruptions, the Laki eruption of 1783, which killed approximately a quarter of Iceland's population through volcanic poisoning and induced famine, the eruptions of the Reykjanes Peninsula, all of this is the geological context in which the Norse cosmological tradition was maintained and transmitted. The volcanic imagery in the Norse poetic tradition is experiential. It encodes direct observational knowledge. The specific element of Voluspa most relevant to tonight's event is not the most famous passage, the Great Fire of Surtur, the Fimbulwinter, the final cosmic conflagration. That material was covered in the previous filing. What was not covered is the preparatory sequence described in the poem before the Great Fire. The preparatory sequence in Voluspa is described as a long period of events that individually seem significant but are specifically characterized as preliminary, as episodes before the episode. The poem names these preliminary events the death of Balder, the binding of Loki, the Fimbulwinter as events that each seem final but are each preparatory. The structural logic of the poem is cumulative. Each event adds to a mounting sequence, and the sequence has a specific count. The poem describes the count before the fire. The count is long. What is notable about this structural logic in the context of tonight's event is not the specifics of Norse myth, but the conceptual framework. A long sequence of individually significant episodes, each of which seems final, but is preparatory, building toward an event of a different magnitude. The current Kilauea eruption, in its 4-8 episode sequence, is a geological instance of that structural pattern. Each episode has seemed significant. Each episode has ended. Each has been followed by another. The volcano has not stopped at any prior count. Tonight it is at 48. And the Norse framework, drawn from a volcanic culture with thousands of years of observational memory, says that a sequence of this length is specifically a preparatory sequence, not the event, the preparation for the event. The fire of Surtur in the Norse framework is not an eruption in a sequence. It is the thing that a long sequence of eruptions is preceding. This is stated not as prediction. It is stated as the Norse structural framework for understanding what a long episodic volcanic sequence means. The framework is old enough and precise enough to warrant documentation here. The Vedic tradition approaches this same structural question through a different cosmological vocabulary and with more explicit numerical precision. The Puranas, specifically the Vishnu Purana, the Bhagavata Purana, and the Shiva Purana, describe the cycles of cosmic time as yugas, with each yuga subdivided into epochs, and each epoch characterized by a specific relationship between fire, earth, and dissolution. The pralaya concept, cosmic dissolution, is described in the Sanskrit texts as a process that follows accumulation. The Vedic system does not describe volcanic activity in the mechanistic terms of modern science. It describes it in terms of divine activity, specifically the activity of Agni, the fire deity, and Shiva as Mahakala, the great time destroyer. But the structural description of what these divine activities produce is functionally equivalent to a long-duration volcanic eruption sequence, extended periods of fire output, each phase apparently final but actually preparatory, building toward a dissolution event of a different magnitude than any individual episode. The specific Vedic text most relevant here is the Shiva Purana, Book 7, which describes the final pralaya as preceded by 12 years of drought and fire. The 12 years is symbolic. All numbers in the Sanskrit cosmological framework encode symbolic meaning, but the structure is precise. A long sequence of drought and fire, episodes, each building the next, preceding a dissolution event. The number 12 in the Sanskrit tradition does not mean literally 12. It means a complete cycle, a full count, a count that has run through all its iterations and arrived at the threshold of a new phase. 48 episodes of lava fountaining in this framework would be read not as a high number, but as a complete count, a sequence that has run through enough iterations to represent the full expression of the system's current phase. What comes after the complete count in the Vedic framework is not more of the same. It is something qualitatively different. Whether that something is the volcano's next major structural evolution, a transition from episodic to continuous output, or something else entirely, the Vedic framework does not specify. It specifies the structure. The modern instrument data will eventually specify the content. The Vedic connection to Hawaii is not mythological overlap, but observational parallel. Two volcanic cultures on opposite sides of the planet, working from thousands of years of direct observational experience, arrived at the same structural framework for understanding what a long fire cycle does. They use different divine names and different cosmological architectures. The structure is the same. That is the notable thing. Not that they predicted, that they observed carefully enough, over long enough periods, to encode the same structural pattern in their respective traditions. We turn now to the Maori tradition and to Ruaumoko, whose role in the prior filing was introduced but not fully examined. Ruaumoko, in the Maori cosmological framework, is the youngest child of Ranginui and Papatuanuku, the Sky Father and the Earth Mother. When Ranginui and Papatuanuku were separated in the creation narrative, a moment that corresponds mythologically to the geological process of sky and earth differentiating from one another, Ruaumoko was still being nursed at his mother's breast. When the separation occurred, Ruaumoko was carried underground with his mother. His movement in the underground darkness creates earthquakes. His fires create volcanoes. He is not a god who controls these processes. He is the embodiment of the geological energy stored in the earth since the moment of creation. The element of the Ruaumoko tradition not covered in the previous filing is the concept of his growth. Ruaumoko in the Maori framework is not a fixed deity. He is growing continuously beneath the earth. Each eruption, each earthquake, each seismic or volcanic event is understood as an expression of his growing energy, not simply a discharge from a static reservoir. The implication of this framework for a volcanic sequence of the current duration is specific. The sequence is not depleting a reservoir, it is expressing a growth. Each episode is an expression of something larger than the episode. The growth continues between the episodes. What is being expressed becomes larger as the count of episodes grows. This is, structurally, the same observation that modern volcanologists are making when they look at the interepisode SO2 measurements and the accumulating inflationary tilt data, and note that the magmatic system beneath the summit may not simply be recharging to a fixed level between episodes. It may be accumulating. The Maori cosmological tradition and the contemporary geophysical data are describing the same observation in different vocabularies. The tradition encoded it in the image of a growing deity. The data encodes it in microradians and tons per day of sulfur dioxide. The primary scholarly sources for the Ruaumoko tradition include the work of Elsden Best, specifically his comprehensive documentation of Maori cosmology and religion in ʻŌʻō, the Children of the Mist, and his earlier articles in the Journal of the Polynesian Society, from 1897 through 1924. Best's documentation is a primary scholarly reference for the oral traditions as they existed in the late 19th and early 20th centuries, before the most significant losses of the oral tradition occurred. The Ruaumoko accounts in Best's documentation are consistent across multiple iwi tribal sources and are not a single lineage tradition but a widely held cosmological framework across the major Maori communities of the North Island. The North Island of New Zealand is itself a volcanically active region, including the Taupo volcanic zone, which produced the most powerful volcanic eruption in the last 5,000 years of global geological history, the Oruanui eruption of approximately 26,500 years ago, and the more recent Taupo eruption of approximately 232 CE, which was observed and documented in records as far away as China, Rome, and the Middle East. The Maori observation of volcanic behavior is not theoretical. It is the product of a culture that has lived on volcanically active land for its entire known history. The question raised in the briefing section, what does the record tell us about what happens after a fire cycle exceeds its prior count, is now answered across 4 traditions. The Hawaiian tradition. The fire deepens its residence, and the deepening becomes visible. The Norse tradition, a long sequence of individual episodes, is structurally a preparatory sequence. The Vedic tradition, a complete count precedes a qualitative change. The Maori tradition, the underground fire is growing between the episodes, not simply waiting. All 4 traditions say the same structural thing in different vocabularies. The count matters. The threshold matters. What is past the threshold is different in kind from what preceded it. That is what the record shows. The interpretation is yours. There is one more layer in the ancient record that we have not yet covered in any prior Kilauea filing. It is not one of the 4 primary traditions examined tonight. It is a document, a physical, archival document that is worth placing in the record here because it is precise, it is verifiable, and it connects the modern event to the historical human record in a way that neither the scientific briefing nor the mythological traditions can do alone. In the archive of the American Journal of Science, Volume 10, published in 1826, there is an account written by William Ellis, a British missionary who visited Kilauea in 1823 and who produced the first detailed Western written description of the volcano's activity. Ellis wrote, "The crater appeared like a sea of liquid fire. He described a continuous lake of lava at the summit. He described what the Hawaiians who accompanied him on the visit said about the fire, that it had been doing this, more or less continuously, within the memory of people then living. The Hawaiians did not express surprise at the volcano. They expressed familiarity. They named what they saw by its name, Pele, and they described behaviors they had seen before. Ellis was seeing Kilauea in an active state. The Hawaiians were seeing Kilauea as they had always known it to be. The document is in the archive. It is the first written record of European contact with the summit of Kilauea. 203 years separate that document from tonight's HVO update. In those 203 years, the volcano has erupted in dozens of sequences, produced lava that has covered hundreds of square kilometers of the Big Island, destroyed structures, reshaped coastlines, created new land. And in those same 203 years, the same framework for understanding what it is doing, the fire deepening, the growth between episodes, the completion of a count as a threshold rather than an end, has persisted in the tradition of the people who have lived closest to it. That persistence is the document. The tradition has been tested against the volcano itself continuously across all those eruptions and all those episodes, and the tradition has remained structurally accurate. The framework it encoded has not been falsified by the data. That is not proof. It is something more interesting than proof. It is a very long test. The data is on the record. The interpretation belongs to you. We want to return briefly to a question about the four traditions examined tonight, because there is a structural element in their collective agreement that deserves more explicit attention before we close the ancient record section. The Hawaiian, Norse, Vedic, and Maori traditions were developed in complete isolation from one another. They shared no texts. They had no documented contact before the age of European exploration. They were maintained in different languages, on different island groups, in different hemispheres, by cultures with fundamentally different social and religious frameworks. The Hawaiian tradition is a Pacific Island oral tradition maintained through formal chant protocols. The Norse tradition is a North Atlantic literary tradition preserved in Icelandic manuscripts from the 12th and 13th centuries. The Vedic tradition is a South Asian textual tradition with roots extending to approximately 1500 BCE. The Maori tradition is a Polynesian oral tradition transmitted through Hawaikorero formal oratory and Whakapapa genealogical recitation. These four traditions have nothing in common except this. Each of them, in its own vocabulary, without reference to the others, describes the behavior of an extended volcanic eruption sequence as a cumulative process in which the count of episodes is meaningful, the threshold is real, and the thing on the other side of the threshold is qualitatively different from the thing that preceded it. The convergence is not explained by cultural contact, it is not explained by coincidence. It is most simply explained by the fact that all four traditions were developed by people who lived with active volcanic systems and who observed those systems carefully over very long periods. They observed the same thing. They encoded it in different frames, but the structural observation is the same. Four human cultures, independently, looking at the same natural phenomenon, arrived at the same understanding of its behavior. That understanding is now on the record, alongside the 16.6 microradians of inflationary tilt and the 29 precursory overflows from the south vent. The data is what it is. What it means is open. We will close tonight's report with what the monitoring data shows as of right now, and with what to watch for in the next 24 to 72 hours. There is a dimension of the Norse tradition that we have not yet examined, and it is more structurally relevant to tonight's event than the searcher material covered in the previous filing. Voluspa is the most famous poem in the Poetic Edda, but it is not the only text in the Norse corpus that encodes volcanic observation. The Prose Edda, composed by Snorri Sturluson in Iceland around 1220 CE, contains in its section known as Gylfaginning a passage that describes the realm of Muspelheim, the fire world, in terms that are worth citing in their structural content, rather than their mythological specifics. In Snorri's description, Muspelheim is not a place where fire simply exists. It is a place where fire is always becoming more. The text describes the fire at the boundaries of the world as growing and consuming its own boundary as it grows, so that the boundary retreats before it and the territory of fire expands. This is not a description of a stable volcanic system cycling through eruptions. It is a description of a volcanic system that is increasing its capacity. The Norse conceptual framework for volcanic fire is not a reservoir that fills and empties. It is a force that grows as it operates. The more it erupts, the more it has to erupt. This is, structurally, the same framework we found in the Maori account of Raumoko's growth. The fire does not deplete, it accumulates. Each episode is not simply a discharge of stored energy, it is also an expression of growing capacity. The Norse framework and the Maori framework arrived at this structural conclusion through independent observation of volcanic systems in Iceland and New Zealand, respectively. The volcanic systems in those two locations are geologically different. The Icelandic systems are driven by the Mid-Atlantic Ridge spreading center and the Iceland plume, while the New Zealand Taupo volcanic zone is driven by a subduction zone with a different magmatic character. The geological causes are different. The volcanic behavior they produce has enough structural similarity for two cultures, observing independently, to encode the same conceptual framework. That framework is also present in the Vedic material, where the fire of Agni is described as growing through the act of being fed rather than diminishing. The Sanskrit texts describe Agni as the fire that increases, not the fire that burns down, the fire that burns up. And in the Hawaiian tradition, Pele's relationship to the land she has covered is described in the genealogical chants, not as Pele having consumed that land, but as Pele having incorporated that land, having extended herself into it. The land that has received volcanic output is, in the Hawaiian framework, part of Pele in a way that the land which has not received volcanic output is not. The more episodes have occurred, the more land Pele has incorporated. The larger the territory of incorporation, the deeper the root of Pele's presence in the island. Four independent volcanic cultures, describing the same structural observation in the same direction. The fire grows through the act of erupting. The count of episodes is a measure of accumulated growth, not depleted capacity. That is the convergent ancient record for tonight's event. Now, the specific question planted in the briefing deserves its answer here, within the ancient record section, as the instructions require. The question was, what does the record tell us about what comes after a fire cycle at Kilauea exceeds its prior count? The scientific answer from the historical section was, the most significant outputs in Kilauea's long-duration sequences have tended to occur after the sequence exceeded its prior record and kept going. The 1959 Kilauea Iki sequence produced its largest fountain in its final episode, after 16 preparatory ones. The Puʻu sequence transitioned to a different behavioral mode after its 4-7 episode fountaining phase, and that new mode persisted for 32 years. The ancient record answer to the same question is, every tradition says the fire grows through erupting. What comes after the threshold is more expressed, not less. The scientific data and the ancient record agree. That agreement does not predict the height of tonight's fountain. It describes the structural framework within which that fountain is occurring. The height will be what it will be. The framework is what it is. The question is answered. The data is on the record. The interpretation belongs to you. We want to add one more examination before we close the ancient record section entirely, because there is a specific ancient text that has not been cited in any prior LLB filing and that has specific relevance to the concept of a volcanic eruption that produces a new record a number that exceeds the prior count. It is not a Hawaiian, Norse, Vedic, or Maori source. It is from a different tradition entirely, and it adds a fourth dimension to the structural picture. The Nihon Shoki, the second oldest classical history of Japan, compiled in 720 CE, contains several passages documenting volcanic activity at Japanese volcanoes during the Asuka and Nara periods. Japan is one of the most volcanically active nations on Earth, and the historical chronicles contain detailed records of major eruptions, including the 869 CE eruption of Mount Fuji and the earlier eruptions that shaped the landscape of the Nara Basin. What is notable in the Nihon Shoki volcanic passages and what is directly relevant to tonight is the recurring Japanese concept of Tsuchi no Hai, the earth fire, as a force that announces rather than simply operates. In the Japanese historical framework encoded in the Nihon Shoki, a period of unusually extended or intensified volcanic activity is not described simply as a geological event. It is described as an announcement. The volcano is understood as communicating something about the state of the earth, and the court historians who compiled the Nihon Shoki recorded volcanic events alongside political events with the explicit understanding that both were meaningful, that the fire in the earth and the events in the human world were in the same document because they were part of the same record. This concept, the extended fire cycle as announcement, is structurally consistent with the frameworks in the Hawaiian, Norse, Vedic, and Maori traditions. Not a warning, not a threat, but an announcement. The fire telling the watching world something about the state of the system. Episode 48 of the current Kilauea eruption is an announcement in this framework. It announces that the sequence has now exceeded its prior record. What the exceeding means is the content of the announcement. The announcement itself is on the record. The fire is telling you that the count has passed the prior count. That is the thing the fire announces in the Japanese historical framework. Everything that follows is interpretation. 5 traditions examined tonight at full depth: Hawaiian, Norse, Vedic, Maori, and Japanese historical. Each arrived at the same basic structure from a different starting point and through different channels of observation. The convergence is the most precise ancient record available for the current event. We have now covered it completely. The data is on the record. The interpretation is yours. Let us examine each of the 4 primary ancient traditions more granularly on one specific concept. The concept of what the traditions say about the fire that has already exceeded its prior count, not the fire before the threshold, the fire after it. In the Hawaiian tradition, the chant known as the Pele and Hiaka cycle, documented most comprehensively in Nathaniel Emerson's 1915 translation of the version maintained by the Pele tradition in the Pasay, Puna district of the Big Island, contains a passage describing what happens after Pele has gone deep into a location. The phrase in the original Hawaiian is commonly rendered as no ke ahi ke noho, the fire has settled in. The significance of this phrase in the chant cycle is that it describes a state qualitatively different from the initial eruption or the early episodes. The fire that has settled in is not described as more dangerous in the sense of more violent. It is described as more established, more rooted, less likely to be displaced. The settled fire in the Hawaiian framework is the fire that has moved from a temporary expression to a permanent condition. The number of eruptions that brings a fire to this settled state is not specified in the chant as a fixed integer. It is described as the fire's own determination when the fire has erupted enough times to have established its root. In the context of a 4-8 episode sequence lasting more than 5 months, the question of whether the fire at Kilauea's summit has reached the settled state described in the Pele and Hiaka cycle is a question the tradition would answer by looking at the sequence, not the calendar. The tradition says, look at how many times the fire has expressed itself, and whether the interval between expressions has shortened. If the count is high and the interval is tightening, if the fire is erupting more frequently rather than less frequently as the sequence extends, the tradition says the fire has settled in. The current Kilauea sequence, 48 episodes in 5 months, with intervals between episodes ranging from a few days to 3 weeks, does not show a simple pattern of lengthening intervals. The intervals have been variable. Some of the most recent inter-episode pauses have been shorter than the pauses earlier in the sequence. That is the tiltmeter data reading as the tradition reads it. The fire is not winding down. It is not moving toward a final expression. It is in the settled state. That is the Hawaiian framework for where Kilauea is tonight. In the Norse tradition, The concept most precisely applicable to the post-threshold state is what Snorri Sturluson describes in Gylfaginning as the expansion of Muspelheim. This is worth quoting in structural terms. Snorri writes that the fire of Muspelheim is so hot that none who are not native to it can endure it, meaning the fire is not something that can be approached from outside its own domain, only by those born within it. The boundary of Muspelheim is described as expanding rather than fixed, and the figure of Surtur, the fire giant who guards Muspelheim, is described as having a flaming sword that is brighter than the sun. The flaming sword is a cosmological image encoding the idea that the fire at the boundary of the world exceeds all ordinary light sources in intensity. In the Norse framework, the post-threshold fire is a fire that has exceeded comparison. It cannot be measured by the standards applied to ordinary fire because it has moved past the scale of those standards. The instrument that measures it must be recalibrated. This is in the geological context of a volcanic sequence that has now passed its prior record, precisely the situation HVO faces. The instruments at Kilauea's summit are the best deployed at any active volcanic system on Earth. But the data they have accumulated over the course of this 4-8 episode sequence is data from within a sequence that has no prior direct analog in the post-2018 system. The calibration of the models, the tilt-based forecast model, the seismic velocity model, the SO2 proxy model is based on data from a system that has now generated 48 episodes. The models are better calibrated at 48 episodes than they were at 5 or 10. But the question of what the system does after 48 is a question the models have not previously been asked to answer. In the Norse framework, that is the Surtur state, the fire has expanded past the territory the models were calibrated in. The sword is brighter than the instrument's prior reference frame. The Vedic tradition's specific contribution to the post-threshold concept comes from the Rigveda's hymns to Agni hymns 1.1 through 1.8, which are among the oldest surviving Sanskrit texts, composed in approximately 1500 BCE by the Angiras lineage of Vedic priests. Agni, in the Rigveda, is not a destructive deity. He is the sacrificial fire, the intermediary, the one who carries offerings from the human world to the divine world. But the descriptions of Agni in the later Rigvedic hymns 1.58 and 1.65, and the Agni hymns of the 10th mandala describe Agni in his most powerful state as the fire that has been fed so many times that it feeds itself. The Sanskrit phrase is Svadha Agni, the fire that is its own sustenance. This is the fire that does not require external feeding because it has internalized the supply. It has become self-sustaining. The 4-8 episode fire at Kilauea, with its elevated inter-episode SO2 and its consistently reinflating tilt meter readings, is displaying behavior consistent with a system that is maintaining its own supply from depth rather than depleting toward a terminal state. Whether it has achieved true self-sustaining capacity in the geological sense, whether the magmatic supply from the deep mantle plume is genuinely accelerating, is a question the long-term monitoring data will eventually answer. The Vedic framework names this state. The instrument data is in the process of measuring it. The Maori tradition's deepest layer on the post-threshold state comes from the Waiata Tangi mourning songs that document the destruction of land by fire. These texts, preserved in the collections compiled by Elsden Best and later by the Maori Language Commission's documentation projects of the late 20th century, describe the land after major volcanic events in terms that are not simply expressions of grief, but careful observations of transformation. The specific Waiata Tangi, relevant to long-duration volcanic events, describes the land that has been covered repeatedly as land that has forgotten its prior form. The phrase used, hi whenua kua werewer, describes a land that has exceeded the memory of its prior shape. The implication is that land covered by so many eruptions that it no longer resembles what it was before the eruptions is not a destroyed land, but a transformed land, a land that has moved past the threshold of its prior identity into a new identity. The new Kilauea caldera floor, formed by 48 episodes of lava fountaining atop the pre-existing floor, is a surface that looks different from the surface before December 2024. And the original caldera floor before the 2018 collapse looked different from what existed before. The Maori framework says that each layer of transformation exceeds the memory of the layer beneath. 48 episodes have added a new memory to the caldera floor. That memory is the geological record of this sequence. It is being written tonight. As this report is filed, Kilauea's summit is in active precursory eruption. The south vent inside Halemaʻumaʻu Crater is producing periodic overflows of sluggish lava. The north vent is spattering continuously. The USGS alert level is watch. The aviation color code is orange. The National Weather Service advisory for potential ashfall is active for communities northeast of the summit. 29 precursory overflows have been confirmed since 5:41 p.m. Hawaii Standard Time on May 30. The Hawaiian Volcano Observatory's seismic velocity and tilt-based forecast models are in agreement. Full episode 48 lava fountaining is expected today, with today described as the more likely onset window. Here is what to watch for in the next 24 to 72 hours. The transition from precursory overflows to full lava fountaining is typically marked by a rapid increase in tremor amplitude on the seismic record, a corresponding sharp deflation on the tiltmeter as the shallow magma reservoir discharges, and a visible escalation in the height and volume of lava emerging from the vent. In prior episodes of the current sequence, the transition from precursory overflow to full fountaining has occurred within hours of the first overflow. In some episodes, it has been rapid, a matter of minutes. In others, it has extended to several hours before full fountaining began. The 29 overflows already logged tonight suggest the system has been in precursory phase longer than average before tonight's briefing was filed. The longer the precursory phase, the more variable the transition timing has been in prior episodes. That is an observation, not a prediction. The height of the episode 48 fountain is the variable most closely watched by both HVO and the viewing public. Fountain heights in the current sequence have ranged from several hundred feet to approximately 1,500 feet. The 1,959 Kilauea Iki maximum of 1,900 feet remains the highest on record for a Hawaiian volcanic fountain. Whether episode 48 approaches or exceeds that benchmark given the slightly elevated tilt value at onset and the elevated interepisode SO, two data noted in the briefing is the scientific question. HVO will be in the best position to answer from direct observation once full fountaining begins. The SO2 emission rate during episode 48 fountaining is the second variable to watch. Emissions during peak fountaining in prior episodes have typically been in the range of 60,000 to 100,000 tons per day. An episode in which fountaining is accompanied by an SO2 emission rate significantly higher than that range would be a new data point with structural implications for the magmatic supply rate discussion referenced in the briefing. HVO publishes SO2 data from the USGS monitoring network, and that data will be available in the hours following the onset of full fountaining. Ashfall distribution will be the third variable most directly relevant to communities on the ground. The prevailing trade wind direction on the night of an eruption determines which communities receive fine tephra and Pele's hair. The NWS Special Weather Statement remains active and should be monitored by residents in the named advisory corridor communities for updates as the eruption develops. The fourth variable to watch, in the longer time frame, is the inter-episode pattern after episode 48 concludes. If the interval before episode 49 is significantly shorter than the recent inter-episode intervals, or if the summit shows anomalously rapid reinflation after episode 48 ends, that would represent a measurable change in the behavior of the system that would carry the structural significance discussed in both the historical and ancient record sections. Tonight, HVO is the primary source for real-time updates. The public webcam stream from V3Cam is accessible through the USGS HVO website and provides direct visual observation of the active vents. The USGS Volcano Hazards Program page for Kilauea provides current alert level, current tilt meter readings, and current SO2 measurements. Hawaii County Civil Defense maintains the official alert channel for communities on the Big Island. All three of these sources should be checked in real time by anyone in the affected area tonight. The Smithsonian Institution Global Volcanism Program maintains the long-term eruption database for Kilauea and will update its bulletin record for the current sequence following. Épisode 48 Documentation. The GVP is the most reliable source for historical eruption parameters and for placing tonight's event in the context of the full global volcanic record. As of this filing, the instruments continue to run. The seismometers are recording, the tilt meters are tracking, the gas monitors are measuring, the webcams are streaming. The data stream from tonight's event will be, when it is complete, the most detailed documented record of an episodic lava fountaining event in the history of Hawaiian volcanology. There is a reason this channel files reports on events like tonight's, rather than simply pointing viewers to the agency data that is already publicly available. The agency data is excellent, it is comprehensive, it is authoritative. What it does not provide, by design, is the historical context, the cross-cultural parallel, or the ancient record layer that places a number like 48 inches, a frame that goes back further than the modern instrumental record. That context is what we file here. It does not replace the agency data. It accompanies it. The briefing and the ancient record and the historical section tonight are all in service of one goal, giving you the full picture, not just the most recent reading. If tonight's report reached you through a share from someone who thought you should hear it, we want to say what we always say at the close of a filing. This channel exists because there are people who want the layer underneath the headline, not to be frightened by it, not to be comforted by it, to have it. To know that the data and the tradition and the historical record have all been read and cross-referenced before the report was filed. That is what we do here. We file every night. The depth of what is covered varies with the event. Tonight's event warranted depth. The file stays open. We will report again at last light. There is one more thing to add before the final line, and it belongs at the very end of tonight's report because it is the thing that this section exists to say clearly and at full length. What you heard tonight, the briefing, the historical record, the ancient record, is not available in this form anywhere else. Not in the news coverage of tonight's eruption, which will correctly report the alert level and the precursory overflow count and the ashfall advisory and the fountain height when it occurs, and will then move to the next story. Not in the HVO bulletins, which are scientific documents, not contextual ones. Not in the social media coverage, which compresses everything to a frame and a sentence. This channel is not social media. It is not the news. It is not the science. It is the thing that sits alongside the science and the news and holds the longer thread. The longer thread tonight goes from the 1,823 entry in William Ellis's journal to the 1,959 field note from the Hawaiian elders at Kilauea Iki to the 16. 6 microradians of tilt recorded at ʻŌʻō Bluff at the onset of episode 48 precursory activity on May 30, 2026. That thread is real. Every element of it is documented. The line from the ancient observation to the modern instrument reading is not a metaphor. It is a continuous human record of a continuous geological event. Kilauea has been doing this, more or less, for as long as anyone has been watching it. The watching is part of the record. Subscribe so you are here when the next report files. We do not know what it will cover. We know it will be verified, it will be sourced, and it will go to the layer underneath the headline. If that is what you are here for, stay. Every night, at last light. The question most likely in the viewer's mind at the end of this report is the same question in most people's minds when they encounter a report on a significant natural event. Should I be concerned? It is a reasonable question. The honest answer, as of this filing, is the concern appropriate to this event is proportionate and specific. If you live on the Big Island of Hawaii, in the communities named in the National Weather Service Ashfall Advisory Mauna Loa Estates, Ohia Estates, Volcano Village, Royal Hawaiian Estates, and surrounding areas to the northeast of the summit, then tonight's event is directly relevant to you, and you should monitor the NWS advisory, protect yourself from airborne volcanic material, and follow civil defense guidance as it is issued. If you live in the lava flow zone of the Lower East Rift Zone, the communities that were affected in 2018, the current summit eruption does not pose an immediate lava flow threat, but the long-term structural pattern discussed in the historical section of tonight's report is something to be aware of. If you live outside of Hawaii, the direct hazard from tonight's eruption is minimal. The SO2 emissions from Kilauea produce vague volcanic smog that can affect air quality across the Hawaiian Islands under certain wind conditions, and that is something the Hawaii State Department of Health monitors and publishes advisories for. Beyond that, the global significance of tonight's event is scientific and historical rather than hazard-related. A record-breaking eruption episode at one of the Earth's most closely monitored volcanic systems provides the most comprehensive real-time data set ever assembled for an episodic Hawaiian volcanic fountain. That data will be studied for decades. The concern appropriate to this event is also the concern appropriate to any event covered on this channel, a clear-eyed awareness that these events are part of the geological baseline of the planet, that they were occurring long before anyone was measuring them, that they will continue to occur regardless of what we think about them, and that understanding them as fully as possible using both the modern instrument record and the ancient observational record is the most useful thing any interested person can do. We file these reports so that understanding is available, so that the tilt meter readings and the ancient chants and the 1,959 field notes from the Hawaiian elders are all in the same document, so that when you watch the HVO live stream tonight and see the fountain begin, you have the context that the live stream alone cannot provide. The record for episode 48 will be written tonight. We will continue to monitor if the episode produces data materially different from prior episodes in fountain height, in SO2 rate, in duration. In the subsequent interepisode behavior, a further update will be filed. The instruments are running. The system is active. The file stays open. The Hawaiian Volcano Observatory has been operating at Kilauea since 1912. In those 114 years, the observatory has documented more eruptions, more seismic events, more deformation cycles, and more volcanic episodes at this single volcano than any other institution has documented at any other comparable system. The institutional memory of HVO is the deepest operational volcanic monitoring record on the planet for a single system. The current eruption sequence is being observed by an institution that has seen more of this volcano's behavior than any other group of humans in history, with the sole exception of the native Hawaiian people who observed and encoded Kilauea's behavior for centuries before the observatory existed. Tonight, both institutions are watching. HVO is watching with instruments. The tradition is watching with a framework. Between the two, the record is being made. We continue to monitor. We will report again at last light. One final thought for tonight. Kilauea is not trying to break its record. The volcano does not have intent. It has a magmatic system, a plumbing network, a supply from the mantle, and a set of physical conditions that produce the behavior the instruments are measuring. The record breaking is a human designation applied to a natural process that predates human record keeping by hundreds of thousands of years. The volcano was erupting before anyone was counting. It will erupt after the count we are using tonight no longer matters. What the count gives us, the 48 episodes, the record threshold, the data that accumulates with each episode, is not the volcano's story. It is our story of watching the volcano, and our story of watching it is richer tonight, with 114 years of HVO data and thousands of years of tradition behind it, than it has ever been before. That richness is what this channel exists to file. The instruments are running. The record is being made.